33.25, which is the actual length of the room, times that by 2, which will give you the actual hertz, 68 hertz standing wave. We're not actually using the measuring system in this one. This equation is basically found online on lynda.com. It's a video that I looked up. We're basically using the speed of sound, which is 1130 feet per second, and we're using the length of the room, which is 33.25, and we're using the equation of the speed of sound plus the length of the room times 2. That equation will give you the actual equals to 68, which is the 68 hertz of the standing wave that's in this room. So we're going to do the test right now. What program that I'm using on here is I'm using one speaker, a monitor, the actual studio monitor, and also I'm using FL Studio that is on the MacBook Pro. So I'm going to open up the program right now, and I'm going to do the test. If you can stand at the 25 foot or the 25% area. First, what I'm going to do is I'm going to do the test right here at 68 hertz. What I'm explaining is this is going to be the node. This is going to be the lowest point of where you hear the frequency at. And then at the 50%, is going to be the antinode. That's going to be the loudest, where you're going to hear the actual frequency the loudest. So I'm going to do the test right here, and then I'm going to do the test at the 50%. All right. Let me know when you're ready.
All right.
All right. You hear anything from here?
Mm-hmm.
Is it faint?
It's like a little faint kind of hum.
Now, the reason why it's doing that is, well, at this frequency, since this is the actual frequency of the room, it's going to give you the actual standing wave that is, traveling out the room. And at the 25%, it's going to be always going to be the, the lowest part of where you're going to hear that actual frequency. So in a situation like that, you would need to know this in the recording industry, because we use these measurements to basically figure out where we need to adjust ourselves to where we need to mix at, or where we set up our studio speakers.
That's way louder.
This back here is going to be a compression to the rarefaction, which is going to come down to the 25%. Then it's going to go back to the compression, which is going to be at the 50%. That's going to be the loudest that you're going to hear. It comes out in a circle. So once the sound comes out, it's going to bounce off the walls, it's going to bounce off the ceiling, it's going to bounce through you. You're going to hear it at the loudest point, and it's going to continue bouncing in this room. That's basically it for frequency.
Computer animators use frequency also by figuring out how much frequency the character we're animating creates by walking or moving. We also get the frequency of the object we are on. For mine, I chose Earth, and I used Earth's natural frequency. Also, it would be helpful to know the weight of what we're animating and how much resistance is naturally on our animation. Then I would use the wave speed formula to get the velocity of my animation. This enables me to find out how much frequency each step pounds back into the earth from my person. In simple terms, it lets me animate realism by making the eye see what I want to portray.